Saxon's Calculus Lesson 49 is about the integral of a sum and then integral of 1 over x. And then they kind of sneakily stick in there a part C, which is the derivative of the natural log of the absolute value of whatever they've stuck inside the absolute value. But the first part, integral of a sum, I'm going to jump into the first example. So it's saying to integrate 6s to the 12th plus 5s plus 3 e to the x plus 4. And all of this is in a parenthesis because they don't want you to think you're just integrating this first part. They want you to know you're integrating the whole thing. So you would work this out individually, just like we derived individual pieces with plus and minuses. That's what you're going to do here. So when we integrate this one, we are doing adding 1 to the exponent, making it s to the 13th. We're dividing by that 13, and of course that 6 is still stuck in there. And then we do the plus, and we do 5 here. Add the 1, that makes it s squared, dividing by that same thing, plus the 3 is there, and the e to the x is still e to the x, and the 4 goes to, because it's implying an x to the 0 that wasn't there, so when I add 1 to that, I get 1. When I divide by 1, it still remains the same. Now, I wrote that as an x because I was looking at that one, but the bulk of these are s's, so I should actually have that as an s. And then because I was integrating, we know we always have the plus c at the end. I don't think they rearrange or shift anything in there. No. Let's look at the next example. Integrate, and again it's in a parenthesis, 6 sine of u plus 5u to the negative 5th plus 3e to the u minus 2. And we're going to do each individual piece again. So this one is 6. And where does sine come from? Negative cosine. So negative goes in front there with cosine of u plus, now my 5 is going to be in the numerator. This u adds 1 and goes to negative 4, dividing by negative 4. So I could have changed that to a minus, but I just didn't know what I had at that moment. Then plus 3 e to the u isn't going to change at all. And then our minus 2, okay, our main one was u. I wanted to make sure I got it right this time. So again, that implies u to the 0, so we're doing u to the first divided by the first, which doesn't change anything, and of course always our plus c. Negative 6, the cosine, they went ahead and made that minus 5/4 u to the negative 4th. You could have changed that to minus 5/4 and then put the u to the 4th as a positive down there. Doesn't really matter. Part B is what happens when we are asked to integrate 1 over x. Now, where do you get the 1 over x from our memorized formats? That came from natural log of x. And so that's what we're going to do in our answer, is just call it natural log of x plus c. Now that I've done the simple piece of that, take a look at example 3. Integrate 4 over t plus 3 t to the negative 1 plus 4 cosine of t plus 3 sine of t. All right, so this is implying 4 multiplying with 1 over t. So isn't that the same thing that we were just doing here? Yes. So that's going to go to 4 natural log of t plus, and this t to the negative 1 implies that if I've made it positive, it's 1 over t again. So this has become 3 natural log of t plus, the 4 is still there. Cosine came from sine, And then our sine here came from negative cosine, so negative 3 cosine of t. Now I can simplify some things together here. This 4 natural log and the 3 natural log, making 7 natural log of t plus 4 sine of t minus 3 cosine of t plus RC at the end. And then their part C, the derivative of the natural log of whatever. They show you an example of sine, and then of course they remind you that when you graph the absolute value of a sine, it changes all of the parts. None of them can go into the negative, so they're all humps. But they basically treat this as a u substitution. So in example 4, they say use a u substitution to find dy over dx, yes, if y equals the natural log of the cosine of x. So we're going to say that our u is the cosine of x, therefore the derivative is negative sine of x. And then this is the natural log of the absolute value of u. So basically the natural log of u, which is going to make it 1 over u du. So that's going to give us 1 over cosine of x multiplying with negative sine of x. So that's going to multiply up here. And negative, did they change that to tangent? I bet they did. Negative tangent of x, because sine over cosine is tangent, and that is your dy over dx. And that was the last example they did on those, although they will come back to doing a lot more of them.